take now another example, and basically guys, this example will be used in further courses. So in later courses, especially for civil engineering, you will use this example, which is the example of parallel force system. So guys, in this example, by the way, this example here is very important, and I remember that last year or last semester we have such example in the final exam, okay? Now here guys, I have some parallel forces. Okay, so I have here a parallel force system where all my forces are parallel, and of course, as you can see here in this figure, they are perpendicular to a plane. So they are all parallel, they are all in the direction of z, so of course they are perpendicular to the plane x, y. Okay, I need to find a simplified equivalent system on the point O, and this is my point O. So basically guys, all these forces could be simplified by an F resultant that is equal to the sum of all these forces, and this is very evident and very obvious. And I know also guys that all these forces will do a moment around O. Okay, so they will do a moment around O, and basically guys, this moment will be in this direction or in this direction. Okay, so why it is in this direction? Because in fact it should be perpendicular to the plane formed by force and the arm, which is from O to any point on F1, and this means guys that this moment should be in this direction. So assume that this is my resultant force and this is its direction. Okay, how can I simplify the system in the best way? Basically guys, I can do the same. So I can pull this F a distance D that is also equal to mr over fr. So guys, the same for here. So in the parallel force system, first of all, F resultant will be parallel to all my forces. So it will be parallel to F1, parallel to F2, parallel to all the forces. M resultant will be perpendicular to the forces, of course, and I can get rid of M resultant by pulling or by moving FR by a distance D that is equal to mr over fr. Okay, so that's it guys. This is how you can simplify the parallel force system. And now guys, the further simplification of the most complicated case. So here guys, I will zoom this example. So this is a very this is a very general case where my F resultant is on Z and my M resultant is not perpendicular to this F resultant as in the case of parallel force system. So how can I have this? So one of you can ask me how M resultant is not perpendicular to F resultant, while we know that the moment should be perpendicular to F resultant or to the force. So I know that the moment should be perpendicular to the plane formed by the force and the arm. So how here M resultant is not perpendicular to F resultant? Basically, this is the case where I have a certain forces. So I have several forces and I have an external moment So basically, guys, I have forces and I have an external moment. So let's say, guys, that these are my forces, they are parallel, and then this will be my F resultant, okay? Then I know that the resultant moment for all these parallel forces should be perpendicular, and it should be in this plane here. It should be perpendicular to this F resultant. So this is basically M caused by, so guys, this is basically the moment of all the forces. Now this moment here could be any external moment caused by a couple. Which means, guys, that my M equivalent, because this is a vector, should be equal to this external moment plus M resultant. Okay, so I know that the M equivalent should be equal to the sum of all the moments of all the forces in the system plus any moment that is external. Okay, and this external moment is usually caused by a couple. It is a free vector, so I can put it whatever I want. So basically, guys, this M resultant here is not perpendicular to FR, which means I cannot move FR by a distance D, and this D will be equal to this M resultant over FR. Because basically this M resultant here cannot be the moment of FR. So I cannot do the same as in the case of parallel force system or in the case of coplanar force system. I cannot move FR with a distance D so that FR times D is equal to MR, because basically MR is not perpendicular to FR. So I cannot do this. So how can I solve for this, and how can I find a very simplified case? Basically, what I can do is to get rid from this M perpendicular. Okay, so what I can do is to get rid from this M perpendicular by what? By moving FR, since this M perpendicular is perpendicular to FR. So I can move FR by a distance D so that D times FR is equal to M perpendicular. And in this case, I can get rid of this M perpendicular. And then, guys, for M that is parallel to FR, since this is an external moment and this is a free vector, so I can put it whatever I want, I can take this M and put it with FR. Okay, so I can have this system here. So this is my simplified system. So in this case, guys, as you can see, I have moved FR with the distance D that is equal to M perpendicular over FR, and I can put this M that is external, okay, which is parallel to FR, on any point on this body, because basically this is a free vector. It is achieved by a couple of forces, so I can put it here. Okay, so this is my MR and this is my force. This representation is called range, and you will also use it in later courses. Okay, so let's now do the inverse. What if, guys, I have directly this system MR that is not perpendicular to FR. So I have an MR here around O and FR. What I should do is to decompose this MR into M perpendicular and M parallel. And then I can find D that is equal to M perpendicular over FR. So basically, guys, in this case, okay, so which is called reduction to range, I have an M resultant that is not perpendicular to F resultant. Okay, so what I should do, I should decompose M resultant into two components, M perpendicular and M parallel, and then two, move FR by a distance D that is equal to M perpendicular, guys, okay? That is equal to M perpendicular over F resultant. And then 3, move M parallel to the same line of action of F resultant as in this figure here. So these are the steps, and don't forget this is because M parallel is a free vector achieved by a couple of forces. Okay, so this is the end of all the cases in the case of the simplification. Now in the following video we'll be solving this problem, and now guys I want you to practice, because I can tell you guys that you will have, of course, 100% sure that you will have a problem on this part. So guys, you will always have a problem on like problem 17 or problem 18 in your next test and in your final exam, and you can have also a parallel system in your final exam or in your midterm. So you will have 1 to 2 cases from these cases in your exams. So please guys practice, and please solve it first of all by yourself and then take a look on the solution. Thank you.